Okay, we're going to apply some more right triangle trig, which is what we've been doing. Find the exact values of the 6 functions of theta using the triangle. Well, first we're going to need the hypotenuse. Remember your Pythagorean theorem. A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. So that's 9 plus 16, which is 25. If that equals c squared, then c must equal 5. So I can fill that in. Okay, and then start with sine. Sine of theta is opposite over hypotenuse. This is going to be my opposite side, so 4 over 5. Cosine of theta, adjacent over hypotenuse, 3 over 5. Tangent theta, opposite over adjacent, 4 over 3. And then I do the reciprocals, the cosecant, flip over sine to get 5/4. Secant, flip over cosine to get 5/3. Cotangent, flip over tangent, 3/4. Okay, you try this one. You're missing a side. You've got to find that first, then find the 6 trig functions. Okay, first you had to use the Pythagorean theorem. 2 squared, we know that side. We didn't know this side, equals 4 squared. So 16, subtract the 4, now I've got 12, the square root of 12. You do need to make sure you simplify your radicals, so this missing side becomes 2 radical 3. That would be the adjacent side, the 2 would be the opposite side. So when sine is 2 over 4, we need to make sure we reduce that to 1/2. Cosine, 2 radical 3 over 4, make sure we reduce the 2 and the 4 to 1 over 2. Tangent, 2 over 2 radical 3, 2's reduce, 1 over radical 3, rationalize it, you get radical 3 over 3. Cosecant, flip it over, you get, flip sine over, you get 2. Secant, flip it over, 2 over radical 3, rationalize, 2 radical 3 over, that should be a 3. And then cotangent, flip over tangent to get radical 3. Okay, this time it gives us one of our answers. Cosine theta equals 3/7. Sketch a right triangle and find the other 5 trig functions. Okay, so if I draw a triangle, put my theta in here. I know cosine stands for adjacent over hypotenuse, which means my adjacent side is going to be 3. My hypotenuse is going to be 7. Now it's set up to be just like the other ones. Pythagorean theorem, 3 squared plus b squared equals 7 squared. 9 plus b squared equals 49. So b squared equals 40. So b equals the square root of 40, which is square root of 4 and square root of 10. So 2 radical 10. Now to get the 6 trig functions, sine theta, 2 radical 10 over 7. Cosine theta, 3/7. Hopefully, because I gave us that one. Tangent theta, opposite, 2 radical 10 over adjacent 3. Cosecant theta, 7 over 2 radical 10, which means I'm going to have 7 radical 10 over 20. Secant theta would be 7/3. Again, that one should be a gimme. It gave you this one, so you should definitely get this one right. And then cotangent. So cotangent theta, 3 over 2 radical 10. Rationalize it, 3 radical 10 over 20. Try this one out for yourself. See if you can come up with the right answer. Okay, see if this matches. Pythagorean theorem, or first cosecant theta. I know that's the reciprocal of sine theta. So if I flip it over, I know my sine is 4/17, which is my opposite and my hypotenuse. So I need to solve for the missing side, square root of 273. And then it's all the same again. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent rationalized, and then of course your reciprocals. Alright, in geometry there's a million word problems you can come up with. Here is one common example. We have a 12-meter flagpole that casts a 12-meter shadow. Find theta, the angle of elevation of the sun. So our angle that's coming up over the flagpole, here's angle of elevation. Angle of elevation goes up. Okay, so if I'm looking for theta, and I am given that 12 and 12, well, the height of the real flagpole would be my opposite side. The shadow would be my adjacent side. And what trig function includes opposite and adjacent would be tangent theta. And we know that equals that 12/12. So tangent theta equals 1. How do you move a tangent over to the other side? You take the inverse tangent. So the theta stays here. The tangent moves. This is called an inverse tangent. Inverse tangent of 1. And then you're going to plug that into your calculator, and you should get 45 degrees. If you do not get 45 degrees, you might want to go to mode and make sure you are in degrees versus radians. To get to that inverse tangent, it's second tan. Other than that, most of this should be familiar to you.